This lesson is on 4.6, which is negative and zero exponents. So the two key things you need to know here is that any time you have any number to the zero exponent, the answer will be 1. So here A could be any number that's except for 0 to the 0 is always 1. So if I had 5 to the 0, it's always equal to 1. Any number. The other is anytime you have a non-zero number, so we'll use A again, and any integer. So if we had A, or if we had 5 to the negative 2, it's equal to 1 divided by 5 squared. We lose that negative sign when we make this into a division. So that's the other key component you're going to need to know, and we're going to do some practice with this. It's converting this negative exponent into a positive by putting it on the bottom of a fraction. So let's do an example. If we had to write this expression, 4 to the negative third, using only positive exponents, we would rewrite this as 1 over 4 to the positive 3. Another example, what if we had some variables thrown in there? So x to the 0 is equal to 1. It loses the x because any number to the 0 equals 1. So we have 1 h to the negative fifth. Well, if we needed this to be positive, we can bring it to the bottom of a fraction. So we could rewrite this as 1 h to the fifth. Now you need to bring the variable with it. You can't leave the variable on top because the variable is the base. So the base needs to move with the exponent. So we could rewrite it as 1 over h to the fifth. And lastly, what if we have this complicated one where now we have a number and variables? So in this case, on the top, we're going to keep the 4. Also, y to the third is positive, so that can stay on top. But z to the negative seventh has a negative exponent, so we're going to move the z and the 7 exponent, make it positive to the bottom. So that's how we would rewrite these. So I'd like you to take a second and press pause and practice with the following 3 examples. The second example is rewriting fractions without using a fraction bar. So how could we rewrite this so it didn't have a fraction bar? Well, to get 27, that's the same thing as 3 to the third, because 3 times 3 is 9, times 3, again, is 27. But we don't want this fraction bar, so we could rewrite this as 3 to the negative third power to make up for that. So that's how we would rewrite 1 over 27. Let's also try it here with exponents. So x to the 8 is fine. That's on top. We're going to keep that on top. But if we want to bring this back up to the top, we need to make it y to the negative 17th power. So now we've done it, and you'll have to be careful and read the instructions to see what they're really asking for, but here they specifically wanted it without using a fraction bar. And I want you to use that same rule, get rid of the fraction bar, and try the following 3 problems in the bottom corner here. So 1 over 100, c to the 4th over d to the 4th, and then g to the 5th over h to the 2nd. Example 3. So here we have using power properties with negative exponents. So find the product or quotient and write your answer only using positive exponents. So forgot my little multiplication sign there, but 10 to the 19th times 10 to the negative 23rd. Well, we know when we're multiplying, we add the exponents. So we'd have 10 plus 10 to the 19th plus negative 23rd. That negative sign does not go away. So in this case, we're going to get 10 to the negative 4th. And we don't want to write it with this negative exponent because it says only positive. So we would rewrite this as 1 over 10 to the 4th. Let's do the same thing here with these, with this fraction with the variables. So here we have 5 is going to stay the same. So we're going to ignore that for now. Let's just focus on these two x terms. So we have x to the 12th minus, what's on the bottom, 14. In this case, we end up with 5x to the negative 2, but we don't want this negative exponent. So we can rewrite that as 5 stays on top over x squared. So that's how you would do it to make sure that you have only positive exponents. So following those same rules, keeping only positive exponents, try these following two problems. And lastly, here's a little more of a word problem, but we're going to do this using negative exponents. So the radius of a proton, you know what a proton is from last year, those tiny things in the center and the nucleus of the atom. The size of that is 1,000 atometers. What the heck is an atometer, you might ask? Well, an atometer is just another unit of measurement, but it's 10 to the negative 9 nanometers. So if we want to find the radius in nanometers, we can use what we've been doing with the exponents to find this. So the first thing we need to do is find the radius of a proton in nanometers by multiplying this radius here by the number of nanometers that's or the number of atometers in 1 nanometer. So here we're going to first start, and I forgot my multiplication again, I'll add them in now. We're going to rewrite 1,000 as 10 to the 3rd. That way we have both with the same base and same exponent. So here we know we can use the product of powers property. We're going to simply add the two here, but it's 3 plus negative 9, which is a negative number, so we're going to end up with 10 to the negative 6, which we don't want to keep it negative, so we're going to move it to the bottom, so it's the same as 1 over 10 to the 6. And then you could move the decimal place to make it a number, so it's 1 over 1 million nanometers. That's the size of a proton, so it's very, very small, 1 part of a million nanometers. So that's how you would use it in this situation. I'm not going to give you a word problem now. We'll see a type of word problem in class, but I hope this lesson was clear. If not, please come with any questions you're confused about tomorrow to class.